Okay, so we're being told that iron wool reacts with oxygen and the iron corrodes and iron oxide is formed. What happens to the iron in this reaction? So all we're doing here is we're adding oxygen. So we started off with iron and we're forming the iron oxide. And if we're adding oxygen, then it's called oxidation. This is the actual practical that we have actually done in class as well. So it says you've got a piece of damp um, iron wool in the top and the measuring cylinder with 50 centimeters as shown. So here we go. This shows the apparatus 1 week later. So you can see what's happened here is that's the start point of the water and the water level has actually risen. Okay. The question then says, complete the results table. So we need to look at the volume of gas in here. So if I'm counting these, I've got, that'll be 49, that's 48. Let's use a slightly different, smaller approach. There's 49, there's 48, there's 47, 46. So this is going to be 45. So the volume here is 45 for 1 mark in the paper. Use the results to calculate the percentage decrease. So what we need to do first of all, let's work out how much the volume is actually changed by. So that's going to be 50 minus the 45 is a change of 5. The percentage change changes by 5, and initially that was out of 50. We then need to times that by 100. So that's going to be, when you work that out on your calculator, that's going to be a 10% change. Marks wise, a mark in here for working this out, a mark in here for doing the 5 divided by 50, and then a mark for your final answer. It then tells us that not all the air in the cylinder has reacted. Give a reason why. That'll just be because the reaction needed more time, so the reaction is going to be incomplete. It just needed more time for the oxygen to react, or maybe a bit more iron to help the oxygen react. Okay, next one. Pure metals can be made useful by converting them into alloys or by electroplating them. Explain what alloying and electroplating is. So we need to do, in our response, I need to do that, and I need to do that, and how they can make metals more useful. So that's kind of a third part, and I need to do it for part 1 and part 2. So let's get into this one. Let's do alloying first. We need to remember that when we make an alloy, we are making a mixture of metals. So we're adding metals together. If you have a pure metal, and I would draw this out, then our particles are the same size and they're arranged nicely in rows. If we have an alloy, because it's a mixture, the particles have got different sizes, and that means that the rows have been disrupted. What I would then explain underneath all this is I would say that in the alloy, the particles have different sizes. This means the layers are disrupted, and this means the layers do not slide easily, and that makes the alloy become stronger, and therefore the alloy is more useful. Argue the opposite as well. So if we have a pure metal, then what we can see here is the particles are all the same size, and that means that if I was to try slide this layer would slide quite easily across, so the layers can slide over, and therefore this metal is softer or more malleable. Other things to say, that alloys, because of this property, because they're stronger, are used in construction beams, also used in aeroplane construction, because you've got corrosion resistance and you've also got stronger materials. Compare that to electroplating. Electroplating is where we cover a metal with a different metal that's often less reactive, and we do that using electrolysis. To do the electrolysis, you put the object you're going to coat is placed at the cathode, and the anode is made from the metal that you are going to coat the other metal with. The electrolyte, the solution, must contain ions of the metal that you're going to coat the anode in. So for example, if I want to coat it in silver, I must have silver ions in the solution. What's good about this? Well, we can take a less reactive metal can be used to cover the metal over. This provides corrosion, just realized it's missed a few letters there, corrosion resistance. It can also make the metal look better, or we could say it can make it look more attractive. And this actually makes it cheaper because you're only putting a thin layer on top rather than making the whole object out of the material. In terms of marks, there are 20 bullet points in there. So what I've done is break down the number of bullet points that you've got and awarded marks for this. Please check and make sure your answer is explained logically because you get credit for that as well. And I'll leave you to work out your marks for that question.